Good morning, all. In today's session, where I'm going to explain load test on DC compound generator. So, the purpose of conducting load test on DC compound generator is to plot the internal and external characteristics. Internal and external characteristics. The internal characteristics will be plotted between the armature current IA and induced EMF EZ under loaded conditions. The external characteristics will be plotted between the load current IL and the terminal voltage VT. Okay. Now, if you see the nameplate details, as it is a generator, we need a prime mover. The prime mover that we are going to use is DC shunt motor. The HP rating is 5. Power rating is 5 HP. Voltage rating is 220 volts. And the load current is 19 amps. And the field current is 1 amp. The speed rating is 1500 RPM. And DC compound generator. The power rating is 5 HP. And voltage rating is 220 volts. Current rating is 13.6 amps. Field current is 1 amp. Speed is 1500 RPM. Next, in order to decide the operators required from the nameplate details, first we have to fix the meter ranges. So here, this is the motor and this is the generator circuit. In the motor circuit, we are going to give a DC supply. The voltage rating of the DC supply that we are providing in our lab is 220 volts, and the fuse is here, and the value of fuse is as the rated current for the motor is 19 amps. We are going to use a 20 amps fuse. Next, field rheostat we are going to use. The field current rating is 1 amp. So we are going to use 300 ohms, 1.7 amps, which is capable to withstand up to the current of 1 amp. So with this, the motor part will be completed. The generator part, we are having two ammeters and one voltmeter. This is plus minus, current entering terminal plus, leaving terminal minus, plus minus, plus minus, and they are of MC type. Now, this ammeter is placed in the field circuit of the compound generator. The field current is 1 amp, therefore we are able to use 0 to 1 amp ammeter. Whereas this is placed in the load circuit, the load current is 13.6 amps, so we are going to use 0 to 20 amps ammeter. Next, this voltmeter as a rated voltage 220 volts, so 0 to 300 volts range we are going to use. And this RG, field rheostat or potential divider in the compound generator field circuit, we are using to vary the field current. So this rheostat is also connected in the field circuit of the compound generator. Therefore, it should have a capacity to withstand up to 1 amp. So we are going to use 0 to 300 ohms, 1.7 amps rating rheostat we are going to use here to withstand up to 1 amp. And there are two more circuits for measuring the armature current, so armature resistance and series field resistance. So here the field supply that we are DC supply that we are going to give is 220 volts, and as armature resistance is less of the order of 2 ohms. If you apply directly 220 volts, a current of 110 amps will flow through the armature. So in order to protect the armature, so is compound generator armature. So here, most of these 220 volts will be dropped across the loading rheostat. Only a small voltage is applied across the armature. So we are going to drop almost 200 volts, near to 200 volts here. So only we are going to apply less than 20 volts. So I am taking 0 to 30 volts voltmeter of MC type, and corresponding to that low voltage, the current will be less than 10 amps. So 0 to 10 amps MC type. So fuse rating will be 10 amps. In a similar manner, we can set the meter ranges for circuit that we are using for measurement of series resistance. It is 30 volts, sorry, not 300, it is 30 volts. Okay, now these meters should be represented in this table. So here 0 to we are going to have 0 to 20 amps meter one number, and 0 to 1 amp meter one number, and 0 to 10 amps meter one number. Okay, next coming to the voltmeters, 0 to 300 volts one number, 0 to 30 volts one number. Next, rheostats, 0 to 300 ohms 1.7 amps, two numbers. Second one also same, so need not represent, right, once again tachometer. Now coming to the experimental setup, so we have to make the connections as given in this circuit diagram. After giving the connections, first the loading rheostat should be in off position. That means all the switches are in off position. Therefore, it is operating under no load conditions. The compound generator will operate under no load conditions. Now, at that instant, by keeping this RF at minimum position and RG at maximum position, we have to close this DPST, and we have to give DC supply to the shunt motor. After giving the supply with the help of starter, we need to start the motor. Once the motor is started, by wearing this RF, we have to bring the motor to rated speed. Once the motor is running at rated speed, the compound generator, which is mechanically coupled to the motor, will also runs at rated speed. Now, when the generator is operating at rated speed of 1500 RPM, by varying this field regulator, we have to bring the generator output voltage, the terminal voltage, to the equal to the rated voltage of 220 volts. Then, under no load conditions, when the generator is generating 220 volts, we have to take the readings of ammeters and voltmeters, and then gradually we have to vary the load. For each step variation of the load, we have to take the meter readings, and we have to make sure that at each application of load, the speed should be maintained constant. The speed should be maintained constant, and the load should be increased from no load to full load conditions. So within the range of no load to full load, we are going to take several readings, and those readings should be tabulated in the tabular column shown here. So in this tabular column, so I am taking few readings from the record to explain the calculations and taking some readings. So here, field number 1, voltage is 220 volts, field current is 0.46, IL is 0. Next, so field circuit ammeter reading, line circuit ammeter reading, and terminal voltage voltmeter readings that we are going to take here. And one more reading, 226, 0.46, 2 amps. One more reading, 4.2 amps. Voltage is 228 volts. Field current is 0.46. And one more reading at 6.2 amps. 230. Field current is 0.46. Another reading at 7.8. Field current is 0.45. Voltage is 234. Next, one more reading, 9.8. Field current is 0.45. Voltage is 234. The next reading at 11.2. Field current becomes 0.44. Terminal voltage remains 234. One more reading at 12.6. 0.43 field current. Terminal voltage becomes 236. So like that, at different intervals, different switches, by switching on the different switches of the loading rheostat, we can take the readings. But at each step, we have to make sure that speed is constant. So as we know, IL and IF, we can calculate the IA value. So based upon the circuit, so here we are conducting the test on short shunt compound generator. Short shunt compound generator. The shunt field winding is in parallel with armature only. So it is a short shunt. For short shunt armature circuit, the IA is given by IL plus IF. IL plus IF. So here the IA value we are going to get as IL plus IF. So adding these two, we are going to get armature current. So armature current values we are going to calculate in this fashion. Now, after calculating the IA value, we can calculate the EG. So, for calculating the EG, we require VL, terminal voltage is here, and IA we have obtained here, and RA we need to find out. ISC is nothing but here, as it is a short shunt, the series field winding is in series with the load. So, ISC becomes equal to the IL. So IL itself will become equal to the ISC. Okay. Now RSC we require. So RA and RSC are required. For measuring the RA and RSC, we can use voltmeter and ammeter method. So this is the circuit diagram for measuring the RA value. The voltmeters and ammeters are connected as in the circuit. So connections are made as per the circuit diagram. Then by keeping this loading rheostat in off position, we have to switch on the DC supply. Then by closing the switches one by one, at each step we have to note down the voltmeter and ammeter readings. From that voltmeter and ammeter readings, we can get the value of RA. Now, if you see the values that we have obtained from record, voltage is 2.6, armature current is 0.9. Next, 6, 1.9. Next, 9.2, 2.8. This gives the value of RA as 2.88, 3.15, 3.28. So taking an average, we will get 3.1 ohms as the RA. Next, in the same manner, by using the voltmeter ammeter method, we can measure the value of RSC. So here, again, we are going to close the DPSC switch with loading rheostat in on position, off position, and gradually we are going to switch on the loads one by one, and each load we are going to note down the readings. The readings will be like this: 0.2, 0.9, 0.4, 0.9, sorry, 1.95, 0.83. So we'll get RSC as voltage by current. So RSC is given by V by I. So we are going to get 0.22, 0.205, 0.26. So on average, we are going to get 0.228 ohms. Okay. Now, as you got the RA value, RSC value, you can get the EG value. So I am doing one sample calculations for measuring the EG. EG equal to VL plus IARA plus ISC RSC. So for short shunt, ISC becomes equal to IL. So VL, if I take 6.2 amps case, VL is 230 plus IA is 6.66, RA is 2.228, sorry, 3.1. ohm. So RA is 3.1 plus IL is 6.2 into RSC is 0.228. So we will get 230 plus 6.66 into 3.1 plus 6.2 into 0.228. Sorry, it's wrong. 230 plus 6.66 into 3.1 plus 6.2 into 0.228. 252.05. 252.05 we are going to get as the EG. So like this, we have to make the calculations for remaining also, and if you complete the table, we'll get the EG value for each load current. Now by taking IL, current on the x-axis and voltage on the y-axis, if you compare, you plot the graph between IL and VL, IL and VL, we will get the external characteristics between IL and VL. We will get the external characteristics, and by taking IA and EG, IA on x-axis, EG on y-axis, we plot the graph between IA values and EG values, then we are going to get the internal characteristics. And the gap between these two will represent the armature reaction drop. Will represent the armature reaction drop. So, with this manner, we can plot the internal characteristics and external characteristics of a compound generator. So, with this, the characteristics of, that is the load test on compound generator is completed. In next class, we will see another experiment.